Good afternoon, all. Today is the second session of AICT PARAKH 5th batch. All are requested to please mute yourself during the session. We will open this forum for question and answer round after the session. Now, I would like to introduce our today's expert, Professor P.K. Garg, sir. Professor P.K. Garg is currently serving as Professor in Geomatics Engineering Group, Civil Engineering Department at Indian Institute of Technology, IIT Roorkee, Uttarakhand, India. He completed BTech Civil Engineering in 1980 and MTech Civil Engineering 1982, both from the University of Roorkee, now IIT Roorkee. He is a recipient of Commonwealth Scholarship Award for doing PhD from University of Bristol, UK, and Commonwealth Fellowship Award to carry out postdoctoral research work at University of Reading, UK. He joined the Department of Civil Engineering at IIT Roorkee in 1982 and became head of the Civil Engineering Department at IIT Roorkee in 2015, and then Vice Chancellor, Uttarakhand Technical University, Dehradun from 2015 to 2018. Professor Garg has published more than 310 technical papers, undertaken 27 research projects, and provided technical services to 94 consultancy projects on various aspects of civil engineering. He has authored textbook on remote sensing, geoinformatics, and digital mapping of soil, edited 3 books, and produced 2 technical films on story of mapping. He has guided 73 MTech and 27 PhD theses. He is a life member of 24 professional societies. Welcome to you, sir. Now over to you, sir. Please take the session. Thank you, sir.
Thank you very much introducing me. And I would like to first of all thank the chairman of CIDC as well as the deputy director, Madam Pratibha Patil, for giving me this opportunity to interact with the participants of this program. And I am told that the participants are from different specializations: civil engineering, electrical engineering, mechanical engineering, and they are all faculty members in a different institution. So it is really a great thing that something has to be covered with the audience with the different specialization and different background. So welcome to all the participants for this particular lecture, which is on disaster. And disaster is a very common topic which is interest to all of us, because we have been experiencing in India in some kind of disaster or the other in different parts of the country. For example, in Uttarakhand, where I belong to, there are several disasters, including earthquake, landslide, and cloud burst is the major disasters creating a havoc kind of a situation. So let me share my slides to discuss further on this particular topic. So let me display my slides. It's taking a while. It is a little heavy. So participants, can you see my presentation? Participants, can you see my slides? Okay. So here
Yes, sir,
we will
will do.
talk about mainly the natural disaster, and since my specialization is remote sensing and GIS, we'll talk about uh, how this remote sensing and GIS can help. So if you look at the word disaster, it is a French word, and it composed of the two words. Des means the evil sense, with evil sense, and astre means the star. So evil stars which are causing the calamity, that is the meaning of the term disaster. And this could be a natural disaster, or it could be a man-made disaster. It could be sudden, it could be slow over a period of time, but they are all affecting the flora and fauna in the environment. So they are disturbing the ecology. They are actually creating a great loss to the flora and fauna on this earth. So when natural phenomena is threatening us, there are loss to physical assets, there are loss to the people uh, when this occurs on the earth. Broadly, there are two types of disasters are there broadly, and one is the natural disasters. It is resulting from several natural processes, and the examples include earthquake, drought, flooding, landslides, volcanic activity, typhoon, hurricane, torrential rains. So these are all under the natural disaster activities. Uh, Human-induced disasters are as a result of the human activity on the Earth's surface. So when we interact with the environment, when we interact with the natural resources, and doing the overexploitation of that, so it is resulting mainly from that. The examples include fire, it could be construction failure. In epidemics, in fact, is considered as one of the disasters. As we have seen, COVID-19, this is also under that category of the human-induced disaster. If there are crashes which are taking place, if there are explosions, that is the human disaster. We are We'll talk in this lecture mainly about the natural disaster, how these disasters are taking place. When we are talking of multi-disasters, because today when we study about the disasters, we do not study in isolation, because at many places, in many states, in our country also, more than one disaster is taking place in a recurring manner. And sometimes what happens is one disaster triggers the another one. Let us say the example of earthquake. If earthquake takes place, then there are chances the landslide will also take place after some time. So we find that there is a link in between some disasters, and if there are multiple disasters taking place in an area, we have to devise the mitigation measures according to that. So earlier we were studying them in isolation, but nowadays we are studying them together, considering what are the probabilities of those disasters in that particular region. So in a region, all may not happen, but definitely more than one could happen. So it is very, very important that we properly manage these disasters. We take some mitigation measures, we make some pre-steps, preparedness, and when the disaster takes place, response to that, how we respond to that disasters, it depends upon our mitigation measure on the preparedness and recovery effects, so that we can actually have a reduced impact. So we recover fast with the affected disasters. There are different criteria for disaster risk assessment, and this is a very general kind of a flow diagram which is shown that how we can carry out the risk assessment from the disasters. So we have to understand the hazard. We carry out the zonation of the hazards, like India has been divided into 5 big zones of earthquake engineering, of earthquake prone zones. So likewise, for each of the disaster, if we could divide the area into different zonations and focus in those areas where the probability is very high, where the occurrence is very high, because you may not require the equal mitigation or similar mitigation measures in all the places. So according to the severity of the disaster, one has to plan. So therefore, it is important that we understand the human vulnerability to the disaster, human losses, possibility, structure vulnerability, land vulnerability, and land use and the activities and the functions which are at risk. And then we carry out the complete assessment of the disaster. Well, there is a management cycle, how we manage the entire disaster, and this is a very kind of a standard diagram, and it starts from the mitigation measures. So mitigation measures are taken on the basis of the previous lessons which we have learned. So we study the history, see the previous disasters which have taken place in that area, and according to that, we take the mitigation measures as per the severity of the disaster, as per the geographical location of the disaster. Preparedness. We prepared for this in case the disaster take place, because you can minimize, you cannot completely stop the natural disasters. So we have to be prepared. We should know what are the do's and don'ts. What should we do in case that disaster take place? What should not we do that? So, like, there are good amount of awareness now amongst the people when they are constructing the buildings to make them earthquake proof kind of a building. So earthquake resistant designs are there for the structures, for the buildings. So this comes under that preparedness. Then when it takes place, then rescue and relief is very, very important, because the people are affected and they immediately need some kind of a support, uh, food and medical support, and then rehabilitation to a new area, because maybe the building has completely damaged or the area is completely flood affected. So rescue and relief is one area where these images, satellite images, and GIS can play very, very important role to provide you the real-time data at the situation. Then recovery and rehabilitation is another one, because you have to provide the support to the people so that they become normal after some time, they live a normal life. And then prevention. So what are the prevention? What are the steps which we can take so that we can minimize, we can prevent those damages to happen in the future? So this is a complete management cycle, and we are taking some mitigation measures on the basis of some structural engineering measures and non-structural. So this is where the the engineering will come into the picture, that what are some those structural engineering and non-structural measures are there. So structural measures could be that maybe strengthen the building to make them more resistant against the cyclone, floods, or earthquakes, or we define the zones. Let us say along a river, we define the zones which are the prohibited zones where construction is not permitted, because this is the floodplain of the region and the river might shift to that area and bring a lot of water someday. So similarly, for each type of disaster, we can take some structural measures there, and there the engineering is going to play very important role. Then there are non-structural measures, and non-structural measures could be, if you plant, for example, trees, vegetation cover, dense vegetation cover, so you can actually protect the area from the landslide or from flooding, flood to spread on both the banks of the rivers. So these comes under the non-structural measures when we have a proper land use planning, when we restrict our activities in the high risk area. So these two are very important when we are doing that. Now, satellite remote sensing, where we can get the images of the area affected by these floods, are playing very important role. And nowadays we have from a coarser resolution satellite image, which can cover a very large area, to a very high resolution satellite images, which can give us a very good information. We can see Google images or Google Earth images, where the Iconos data is uploaded, and you can see behavior of the river, you can see the pattern of the river, you can see the flood, you can see the damaged building during the earthquakes or after the earthquakes. So all that information nowadays one can see through these sites, Google Earth sites. A lot of images are uploaded, and these are
சுருண்டுதான் நிக்க முடி கீழே விழுந்தா இந்தாடி பல்ல விளக்குனியா இல்லையா உனக்கு வேணுமா உப்பு
please switch off your
கொடுக்கமா வாமா
audio. Please switch off your audio. Somebody's audio is on, please switch off your audio. So you have very high resolution satellite images where you can identify the losses. Very important. Now we are using, as you can see in this diagram, the space technology is playing very important role, not only for disaster mapping, I mean giving you the real information about the disaster, but managing it for the future. So you can maybe do some kind of a prediction also. Then you can use it for providing the relief, because the government is interested. Once the disaster is taking place, the government, the administrator are very much interested to know how much is the loss in the area, and that loss is converted into the funds. How much funds are to be released, how much food supply is to be given, and what is the way, whether there is a cutoff from the road and the railway line. So all that information one can get immediately from those high resolution satellite images. Prediction, as far as the prediction is concerned, you must have seen there are good success in that also, using the space technology. Whenever some cyclone hits Orissa region, or the coastal region of our country, so some warnings are issued to the people well in advance, so that they are away from the coastal area. The fishermen are not in the sea, and this way the losses are minimum, and one can take proper measures for the preparedness. So these images, these satellite images of the space technology, is helping us to predict on the basis of certain parameters. When we have temporal images, time frame images, then we can actually assess the severity of the disaster using these images. And also now we can find out which are the rehabilitated area, which are the safer areas where people can be rehabilitated and they are not affected by that kind of disaster again in that area. So pre-disaster and post-disasters mapping and management can be done. Now we have lots of satellite images now. So those who are dealing with those satellite images might understand we are working in the taking the images in different part of the electromagnetic spectrum, and this is that electromagnetic spectrum which is shown a part of that. So we have images which are taken in the visible part of the spectrum, short wave infrared and long wave infrared, and then further divisions of that are shown as multi-spectral images. So we have more than one image basically for the same area taken by the same sensor and same satellite. Then we have hyperspectral, and then we have the ultraspectral. So if we divide that region, visible part of the spectrum, if we divide further into smaller regions, we get more than hundreds of the images which we call hyperspectral images, and more than 1000 images will be ultraspectral, where one can see very detailed information. So if we talk a little bit more about those satellite images, it is showing you here different kind of images. On the left side, you can see AVHRR or MODIS, where the resolution is slightly coarse. Resolution means the size of the pixel or the amount of detail which you can find out. So you can get only a broad area because the pixel size itself will range from 250 meter to 1000 meter. But the advantage here would be, as you can see, that it will cover a very large area, 2048 kilometer by 2048 kilometer area, one single scene, one image, and you can get global coverage every second day. So for the whole area, now every second day you will get the image. So there are certain type of disasters where you require images more frequently. So maybe a flood, maybe a earthquake, maybe a cyclone kind of thing, where you require very frequent images to understand the situation on the ground. But if you go down the lane here, you can see the commercial system at the end. And these commercial systems are giving us very, very high resolution images, 1 meter, 5 meter, and nowadays we can get less than a meter also, 30 centimeter. So it means any object which is 30 centimeter by 30 centimeter in dimension, we can identify. So each and every building, one can identify if there is a damage to the tree, vegetation cover, individual tree, that also can be identified. Now the area covered is small, 20 kilometer by 20 kilometer, one satellite image will cover. So that means if you have to view a larger area at higher resolution, then you require several of these images and you join them together, and then you can study the whole area. So you get global coverage, but the image which you will get will not be that frequent. It will not be every 2 days image. So if you want a global coverage, it will take several months together, in fact, to stitch those images and carry out the operation. Also remember, please, the cost of the image. Nothing is free here. Cost of the image is also associated with the kind of the resolution. Higher the resolution, higher is the cost of the. So if you want to procure, say, coarser resolution images from AVHHR or MODIS data, then it is not that expensive as the commercial systems images with high resolution, but you procure number of images to cover the same area. So remote sensing we can use for example, feature extraction and map updating. So if I want to extract, suppose the road network, because road network is the communication network. In case of a disaster, it is very, very important that I must see my road network, whether access is there or road is damaged to reach to the people by road. So feature extraction can be done with the help of the satellite images, this shows building extraction. So each and every building, whether it is a residential building or it's a commercial building or it is the official building, that all you can identify and carry out the extraction of that from the high resolution satellite images. Uh, Green area extraction. So which are those open spaces? Because you need the details of that. Suppose there is an earthquake, so these spaces are very important to us. You can extract the green space from the satellite image, and you can superimpose everything and can use it for um, drought management. Now, in our country, tsunami came in year 2004. Prior to that, many people were not aware what the tsunami is, and they were really not clear that how much damage a tsunami can make to the area. So this is the satellite image from our Indian remote sensing, where left side is showing just prior to on 21st of December 2004. This is the image of Trinket Island. So you can see the Ireland is shown in the pink or the red color. Red color is indicated uh, by the vegetation cover on the false color composite of the satellite image. So one can see very good ocean water with two colors, very dark blue color and the light blue color. So prior to the tsunami, the image is so clear that you can identify the Ireland. You can see the shallow water and you can see the water which is basically deep water. But right side image, where the circle is there, yellow circle is drawn, one can see on the right side that it is completely damaged. So the water has entered and a lot of muddy water has entered into the area. So you can see the color of the water has completely changed and it has damaged the uh, Ireland. Also, one can see a lot of cloud cover. Those white hanging patches are the cloud cover. So one can carry out pre and post kind of a study and find out how much is the damage to the area. So this is the another example of in the hilly region example of the bust of the river, the bust of the storage of the river. These markings are done on the two sets of the satellite images, and you will find there's one before and one is the after. The after satellite image is showing that water everywhere, and because of that, you can see a lot of cloud cover. So these are the images of the hill region where a lot of damage was done to Gangotri, Kedarnath, Gaurikund area, Hemkund, Badrinath, and the Roorkee area. Now, all that data which you are collecting from the satellite images, you can use the capabilities of the GIS, Geographical Information System. So this GIS is nothing but a combination of the hardware and the software, where you are actually giving input data from various sources and analyzing these sources, analyzing the data from collected from different sources. So this slide shows on the left side the unit which is called GPS unit, Global Positioning System unit. We are all familiar with the GPS unit because we have GPS in our mobile, we have GPS in our automobiles, car, navigation system. So these GPS are slightly different because they are the chips in your system. These GPS, which I am showing you, are different in the sense that they are used for mapping purpose. They are giving you a better accuracy of the coordinates, X, Y, and Z coordinates which you are collecting from the data on the ground. So when you are taking this, this is a handheld device, but there are costly equipment also which can give you very high accuracy. So when you are working in a very, very large area, probably the handheld GPS will serve the purpose. So the data is being collected from the GPS, and since we get three-dimensional data, which is X, Y, and Z, so you can directly import this data, of course, after processing with the software to remove the error during the field data collection, import it into the GIS, and then you have the data from the satellite image, can use these data together to carry out the analysis in the GIS. So if we look at the GIS, it has several components, and the component is we are using some kind of a hardware. So nowadays the workstation and any high-end PC will be sufficient. Then we are using some kind of a software. So there are software like the ISRI software, ArcInfo, ArcGIS software, or there are open source software as well. We can use these software and also the data products. So data could be the satellite image, or it could be some other image collected from the drone system, collected from the aerial photography or LiDAR based systems, and then we are actually using people from the different specialization and different background, because our problems may be a multidisciplinary in nature. So if we are, for example, today talking about the earthquake disaster or landslide disaster, we need a person from the geology background. We need a person from the meteorology background. We need a person who is socio, economic specialist. So different people from different background are required in order to understand the problem and to derive the results. Now, when we are doing a hazard mapping from GIS applications, we are actually working at a different level. So second column here, it is showing you whether you want to work at a national level, or you want to develop a regional plan, or a district level or municipality level, or maybe just wanted to carry out this kind of a analysis or mapping at the field site. So it depends how big is your area. If you now see the first column, we decide about the mapping scale. So each map has a scale. So those who have dealt with the maps, the topographical maps and the other maps, there's a scale of the map. And this scale is important to determine the distance between the 2 points, to determine the area. So all the measurements you can do with the help of the scale. Once you know the scale, you can determine the ground distance or the area of a particular figure. Now, third column shows that, for what purpose you can use the GIS when you are working at a different level, when your area is from very large area to very, very small area. And the last column shows data requirements. So what is your data requirement? Because the satellite data, as I have shown you, they are available at different resolution. So if you are working at a national level, let us say your application level is national, then you cannot go for a very, very high resolution satellite data, because you need very, very large number of satellite images, and each will cost you money. So even the procurement of the images will cost you a lot of money. So we have to, according to the application level, we have to make selection of the satellite images. So in the form of the maps, if you have to show the area, we are showing something like that. So this is the volcanic activity areas. So areas which are highly active volcanically, they are shown by the purple color. So drought prone area is shown here by the brown color. So similarly, the earthquake prone areas are shown, and these are the flood risk areas, which are shown by the blue color in that region. So landslide areas are shown. So what I'm showing you here is the same geographical area, but different kind of disasters are there. As I told you in the beginning itself, that there could be more than one disaster present in the area. So different disasters are there, and you can actually carry out the impact of that. This is the earthquake disaster map. This is the volcanic activity map. Then this is the other kind of a disaster, landslide area. So you can uh, study them, drought disaster, you can study them together now in combination. So you can do the overlay operations, and GIS is very, very useful, in fact, to develop a decision support system. And this is what we require actually. Administrator require a support system in case of a disaster take place, uh, to uh, take the right kind of a decision at the right time. Now, this remote sensing and GIS based output, what will be my output, the results which I can derive? I can have a risk mapping, I can have the vulnerability mapping, I can have the hazard mapping, I can have a 3D visualization. This is a new and upcoming area where I can see the whole of the terrain in the third dimension. Now, this is, for example, the GIS based output which we create, and this is the multi hazards zones in we have. So they are showing different colors, are showing the different intensity of the hazards, of multi hazards in the area. So that means more than one. As you can see in the index, there could be earthquake disaster, there could be wind, there could be a cyclone, right? There could be a flood. So effect of the multiple disasters in an area. So this is the, for example, the Gujarat, what is the frequency in every 200 years, the earthquake hazard. So from high intensity to the low intensity areas, they are shown. This is Orissa Mahanadi flood hazard in last 100 years. So what is the intensity from high to low? So these kind of maps, when we have some kind of a historical data attached to that, and on the basis of the historical data they have been analyzed, it helps us to identify those areas which are highly vulnerable. That means if there is any structure constructed in that area, if there is any activity which is to be carried out, one has to take sufficient measures because we know the history of that area. This is the Andhra Pradesh cyclone, right? So you can see that the entire coastal region from high to low. So that means that these are those areas where construction should be prohibited. Then the GIS is actually playing very, very important role in the risk assessment. If it takes place, how much is the risk involved? What are the parameters or what are the components which are affected? And then we can actually plan the mitigation facilities, like which could be the potential sites for emergency camps, which could be the potential sites for fire station, medical facility, what will be the safe route, what will be the source of the water into that area. So we can actually carry out all those activities right from the preparedness to response to relief, recovery, and the prevention, everything in the GIS, provided we have the data available and recent data available. So GIS can be used, for example, for a very, very large number of activity. As you can see, event mapping, when it has taken place, pre and post, pathfinding, route analysis, because this is also very, very important in case of a emergency service, like police, the fire, and the ambulance. We have to find out which is the route to reach there, because many of the routes will be damaged due to that disaster. Hazard visualization and mapping is one area where one can see the effect of that on the terrain. You can simulate the scenario. A lot of studies have been done on this particular aspect, assuming that this is the intensity of the earthquake, what is likely damage if this kind of earthquake takes place. So several studies have been done on the basis of the scenario simulation, and you can have the emergency response operation and risk analysis. Now, link Earth observation to societal benefit. This is very, very important. We might be doing very high level of research, but what is the benefit to the society actually from that research angle? So benefit of the society is directly when you are using remote sensing and GIS, the uh, best advantage of that is the Google interactive map, which you are using uh, to find out the location or to find out the shortest route. So this is the level of the benefit which has reached to the society. Also, you can actually develop early warning systems, and a lot of studies are going on in India and abroad, where uh, early warning system or advanced warning systems are developed or being developed so that less and less damage to the people is done, because you cannot completely prevent the disaster, but you can certainly minimize the effect by using the technology, appropriate technology, right kind of a modern technology. So this early development of early warning system is very, very important, and this is one of the uh, again greatest societal benefit. If we could develop some kind of a system which could give me early warning from the flood, early warning from the earthquake or landslide, then probably the people of that area could be warned. So this kind of work is going on uh, at many places. So I'm showing you basically here some kind of a study where what are the parameters which are required to be studied when you are developing some kind of a early warning system. So you have to carry out some kind of a prioritization and some kind of a ranking as far as the flood, drought, earthquake, fire, these hazards are concerned. Then seismic and tsunami hazards are there. So GPS, people have installed GPS devices, people have installed wireless sensors which can provide us the data, continuously monitor that area. So what is happening is, in case of the seismic hazard which is taking place, there is a release of the strain, and there is a widening of or movement of the thrust area, the fault zone and the fault zone. So if we can monitor somehow, if we can install the GPS stations regularly to monitor that area, because we know the plate moves, the Russian plate is moving over the Asian plate. So because of that, these two plates strike together, the earthquake is taking place in India. So can we monitor the movement? And if there is a movement observed beyond a threshold value, can we issue the warning to the people? This is the kind of a approach it is being used, and GPS stations have been established, and they are continuously monitoring the data and providing the data through the IoT, Internet of Things technology, through wireless technology, and this data is being analyzed at a central server, and the warnings are issued on the basis of some kind of a threshold value. So this is all, it is showing that how the technology, which is the satellite technology, communication technology, and our sensors, our GPS stations are helping us actually to detect the seismic waves or to detect the slight movement of the earth, and communicate that to a warning center, and from warning center the communication will go to the administration or the general public. So I'm showing you here seismic hazard in the microdonation, because looking into the loss of the buildings, microdonation has been done for several cities, because the behavior of the each building will not be different. let us say in case of the earthquake, some buildings will be completely damaged while the other buildings may not be damaged at all, or just cracks are coming in that building. So the micro duration is very, very important, that we have the damage scenario of each and every building. So we can have that once we have the history of each building, once we have the data, sufficient data, and that can be collected nowadays. There is one approach, and some of you must have heard. It is called BIM, Building Information Modeling. So when we are using the BIM approach, we have the entire data about the building inventory, building construction, and also the data about the topography, the geology in that area, fault, what is the hydrology, what is the soil characteristics, and we create some kind of a seismic vulnerability map. So we have the data for each and every, this is the micro-zonation map, for example, for the Jabalpur MP area, based on the kind of approach which I have shown you in the previous slide. So this kind of a micro-zonation is helping me actually for future planning of the city, for future expansion of the city. You must have heard about the smart city concept. And in the smart city concept also, this micro-zonation map is very, very important to me, because I will not like to have the buildings, new buildings, multi-storied building coming up into the areas which have high vulnerability. Now, this is one study here of Dehradun region, and I'm showing you the simulated study. That means the earthquake has not occurred, but earthquake has been assumed that if it occurs, what is going to happen in that area. So one can see on the satellite image that there is a block, Dehradun block, which has been actually marked. So how the Dehradun city looks like from high resolution satellite image. This is a black and white image. You can actually see buildings, you can see the road network, you can see open land, you can see the green vegetation cover. So this is so detailed. When you zoom it up, you can even see individual vehicles on the road which are moving. So very detailed information one can get. So can we carry out the mapping of these are the different ward in the area. In a block there are wards, so different wards. It is Dalanwala ward, and which has been mapped. So now you can see that from high resolution satellite image, you can carry out you can prepare some kind of a map which shows that which are your religious buildings, which are the commercial area, which are the residential area, which are the open land. So you can get the statistics of each and every landmass. Now in the same Dalanwala ward, you can get the size of the household. What is the size of the household? So that also you can actually carry out the mapping of the household size. So according to the household size, you can do the distribution. Now each of this building has a number of floors. Some might be high-rise buildings, some might be G+2, some might be G+4. So all that has to be mapped. Now this information you cannot probably get directly from the satellite image, and you have to go to the ground in order to collect the data for each and every building. Then the next is the building construction type. What is the material for which the building is used, and what are the design of that particular building? So that is also you can collect from the ground itself, that what is the building construction type. This is the A type building or C type building. Now you assume that there is an earthquake in the area at 7 Richter scale. So what is going to happen in that area if there is an earthquake? So you can see the statistics is written here. What is the damage rate in percentage? So at 7 Richter scale, if the earthquake takes place, what will be the damage rate in the area that is being shown? But if the earthquake is of slightly higher intensity. So one can see that the damage rate is increasing very rapidly. From 7 to 9 it is done. So the 80% of the buildings would be damaged. Then if you make it further higher, then you can see more red and orange kind of a shade in the area. So the percentage would further increase. That is what it shows, that uh, most of the buildings will be completely damaged. So that kind of a scenario one can create in the GIS. So this is the advantage. You create a scenario, and in case the earthquake of that intensity takes place, you know which are the vulnerable areas, we know which are the buildings which will be completely damaged. Now you can see what will happen is that when the buildings are damaged, some buildings will collapse on the road, by the side of the road, and you have a lot of debris on the road. So in a way, your transport is affected, your roads are blocked. When your roads are blocked, then the movement of the people, you are cut off from the rest of the people. And this is happening very frequently in landslide in Uttarakhand. When there's a landslide, heavy landslides, the material comes on the road, and the tourists, they are completely cut off from each other, and it takes sometimes several days to clear that debris. So similarly, in the case of earthquake, this slide shows that what happens is that when the different buildings are collapsing, and it depends upon the simulation which you have carried out, you know that which are closer to the road, the buildings which are closer to the road, by the side of the road, a lot of debris will come onto the road, and road will be completely blocked. And in case you want to give some relief measures to the road, you cannot do it. So this is a 3D model of the buildings. The different buildings are shown by different heights, and you can actually create the entire 3D model of the area, and then you can see that the damaged part is that the coffee color is showing a complete road blockage is there in that area. So you can actually create this kind of a scenario in the GIS environment, that the buildings which will collapse, you can now correlate with the age of the building. Maybe the building is old, or maybe the building has not been maintained properly, maintenance required. So you can now correlate the things together, that what is the reason why some buildings are behaving differently than the other buildings, and which is the area which will be completely blocked. So you can see the areas which are blocked by the building debris, the roads. There are certain roads which will be completely blocked. There are certain roads which are visible to you. So that means the transport is possible. One can go reach to the people. But when the roads are completely blocked, then you are cut off, and it's very, very difficult to provide relief to the people by road. Then you have to use some other means, airborne. Then this is the risk modeling due to the earthquake. So you have, for example, a risk map, you have the seismic zoning map, similarly the population density map, and one can create actually using different kind of a steps. So these are the steps. I'm not going to explain you these steps in the details, but just to give you an idea that you are using a certain technical procedure in order to create the risk map, in order to create the. So this is that complete flow diagram where you want to carry out the hazard zonation study from landslide. So the only thing is that you have to first of all understand, whenever you are studying a disaster, what are the parameters which are affecting directly or indirectly to that, which are contributing directly or indirectly to that disaster. So you have to collect the data about those parameters, and then integrate them into the GIS, so that you can get the true picture of the ground. So these are some of the parameters which I am showing you. for landslide hazard mapping, which is on the lineament map, a drainage map of the area, then digital elevation model which you are creating from the elevation data or contour, and then you are creating a slope map of the area. Then the geology map, a land use map which you can create from the satellite image, and then and out of that you can see there are some active landslide and there are some landslides which may not be active. So this is the kind of the landslide hazard mapping which you can create, and you can see which are the areas which have high probability, which are the areas which have moderate, low and very low probability. So pink are those areas where the probability is very high. So that means that kind of a treatment, kind of the management of the landslide which we are doing there, this is not exactly same everywhere, but according to the intensity, maybe your highest priority will be where the probability of the landslide is high. So this GIS is a very, very useful tool actually to not only carry out the landslide mapping, you can carry out the susceptibility and also can compute the loss. So what is done mathematically, there are some weights which are given to different factors. So there is a well-defined statistical procedure, analytical hierarchical process, AHP process, and sometimes we are using this AHP analytical hierarchical process in GIS also. So in order to define the relative weights to each of these parameters which are causing landslide, let us say, because every parameter may not be equally responsible for that. Some parameter may have higher importance than the other. So we have to do some kind of a statistical kind of analysis in order to find out the relative ranking of the weights. Which parameter should be given higher weight and which parameter should be given lower weight. So these are the different parameter: distance from the earthquake or the slope parameter which has been given. Further weight ranking, then land use length or classes, rainfall is triggering the landslide, lithology. So these are three parameters which are shown here, and they have been given certain ranking. So all the weights are assigned to different parameters, and then one can integrate actually all these parameters together to find out what is the impact of these parameters on different landslides. So this is a human induced, for example, a landslide map. So in the entire area, which are the landslides which are not natural landslides, which are human induced landslides. So one can see 5 categories from very high susceptibility, which is the dark red here, to dark green color is the very low susceptibility. Then human induced most susceptible areas, the dots are there in that area, and this is in Uttarakhand region. So one can actually see on once you identify that, you can cross check also on the ground. This is important. You carry out any kind of a modeling in GIS, any kind of analysis, any kind of results you are getting, unless and until they are not validated on the ground, nobody has the confidence to use your results. So this is the validation part of that, those particular dots location, one of the location where coordinates are also given on the Google Earth image. So one can actually either physically visit, but nowadays very good source of data which is available to us is the Google Earth high resolution images. We can see how the area looks like. So we found that the vulnerability site which were identified by those parameters are matching with the images which are on Google Earth. Then there are naturally triggered landslide. So it could be either due to cutting of the vegetation cover, or it could be uh, it could be due to the rainfall, heavy rainfall in the area, or maybe some um, earthquake activity has taken place, and after that the landslide has occurred. So one can actually map them together also. Now, um, this is the example, how you can automate the things together, because it is very, very important that we reduce the um, the manual kind of a analysis work, because when some disaster will take place, we should not take several months together actually to derive the results. So results should be quick, very fast, and there should be some kind of a automation in the process, so that one can get the results very quickly, and these results help in taking the decision to the administration. So this is a kind of a model which has been developed in one of the study here at Roorkee, the landslide prediction model. So it will try to predict the landslide in advance on the basis of the triggering parameters, on the basis of the parameters which are responsible for creating the landslide. And the advantage of this prediction model is that once you predict in advance, then probably on the basis of the truthness, accuracy, you can develop the warning system. So this is one step in developing the warning system, is the prediction. So these are the different uh, parameters where one has to actually give the values to that. For example, this is for rainfall. So you have to define the rainfall parameters in that area. Then if there is a new earthquake location, then you have to actually give the location in terms of the XY coordinates. Then new habitation, etc. monitoring. This is the new landslide location which you have to enter into the system. Then you can give some more information about the different layers, different parameters which are required. So you can select the parameters here from the drop down menu and select those different input parameters which are required to run this particular model. So you can get output something like this. So landslide prediction model. So this is predicting, this is the landslide could happen, very high probability to low probability is shown. So for example, this is the uh, landslide validation at those locations where the dot is shown, and one can verify the results of the model actually on the ground. So once you are sure that the prediction of the results are 90% or more accurate, then probably it could be used for developing a warning system. Then this also tells us which are the safest area in the region. So it will actually create a buffer around a particular landslide, and outside that buffer it will find out the safer area. So this is the details which is producing by the software, and what is the slope, what is the rainfall at that particular location in case the landslide. And then this is the kind of a warning system. And this warning is in terms of the email which is sent to the people in the database, or maybe in terms of if you have the mobile phone number database, or there could be any other means of communication. So, but the mail systems or the phone number, mobile number, they are the best nowadays to communicate with the people. So some kind of some warning could be given in advance. Now, since when we are working in the area, sometimes the area is very large. So this shows that, how our 3D mapping systems, mobile mapping systems are helping us in collecting the large amount of data. So this is a vehicle-based mounting system where you are keeping your GPS on the top of the vehicle, you are keeping your cameras, you are keeping your scanners, which will scan actually the whole of the topography of the area. So this is showing the output, which is all we call it the point cloud data. So you are getting the point cloud data. On the right side, you can see a road. This is a hilly road, and on the both sides of the hilly roads, if there are landslides, you will have very accurate coordinates of that with the help of this particular device. Then drones are being used, what we call as the unmanned aerial vehicles. So unmanned aerial vehicles have been used actually to carry out to collect the accurate data of disaster stricken area. So whenever the disaster, either flood or earthquake or forest fire, the advantage of these drones are that you can send these drones anytime to that area, and they will collect the data and come back to you. So you are not dependent now on the satellite image, that you will get the satellite image after few days interval. So as soon as you come to know that disaster is taking place or likely to occur, then you can start collecting the data from a much lower height. So you get very high resolution images. You can get uh, very accurate data from that. So this is example of the forest fire. For example, the Uttarakhand also has actually a lot of forest um, in the hilly region where fire has started taking place. So yesterday it was in the news that internationally there are many countries which are facing this problem with the intensive heat. So the drones are actually used not only to know the extent of the fire, but also in which direction the fire is spreading and what are the measures which could be taken to further spread it. This is the data collection for the earthquake prone area, the damaged part of it. Then this is the hazard visualization of the hazard in the third dimension, because you can see the earth in the third dimension. So 3D visualization is very important. So this shows the flood which is spreading actually wherever the slope is less, the flood is spreading into the area and creating the damage to the surrounding land. One can carry out similarly the hydrodynamic modeling, which are the buildings which are submerged when there is a flood. As you can see on the left side, the river carrying a lot of water, and the blue color indicate the flood water which had spreaded into the habitated area. So there are buildings which have completely submerged. There are some buildings which are at the higher ground, which are little safer. So one can find out the extent of the damage, the loss, and the safer area, so that the rehabilitation work could be taken up. So this, remote sensing and GIS activities are permitting us to detect both type of the hazards, whether it is the natural hazards or it is the human-induced hazards. So there is a need actually to have the research and capacity building in this particular area, and I am very happy that very large number of participants are listening this lecture, and um, the CIDC is doing wonderful work to do the capacity building work in different specialization area. So there is a need for capacity building in the field of space technology, because this is the technology which is very useful, which can not only provide the information about the disaster, but it can be used for disaster management and developing the early warning system. So this is all about my lecture. Thank you very much for your kind attention.
Thank you, sir.
Yeah.
If anyone has any question, please come forward and ask.
Right.
Sir,
I think
there is
there.
question in the chat box, sir.
Yes, there's a question. Probably somebody is asking where I can get the satellite images. Okay, because these images are required in order to carry out the analysis. So what is no? Let me okay. Let me first of all, my slides are visible. So let me first of all remove that part. Okay, now. So satellite images you can procure in India from NRSC, National Remote Sensing Center, Hyderabad. But if you don't want to procure those images and you want to work on the previous images, previous means 2 years and older images, you can get them free of cost. Some of the images are available on Bhuvan, BHUVAN. Bhuvan. This is the Department of Space ISRO site where you can download the data. Also, there is a USGS, United States Geological Survey site where American satellite data you can download. So there are Sentinel data which you can download free of cost. So there are several sites where you can free download the data, but if you want the recent data and you want very, very high resolution data, then you have to procure from NRSC Hyderabad from our country. There are two questions. I don't know what is the other question. I think so. Mr. A. Udhya Kumar has also a question. So he can ask A. Udhya Kumar? You can ask the question. Questions?
Udaya Kumar has raised your hand. Please ask the question.
Please ask
If you
the
have
question.
any question, please ask.
Yes.
Mr. Udaya Kumar.
Anybody has any question, you can ask.
Sir, good evening, sir.
Yeah.
Yeah, this is Dr. Gulakshmi from Research, Chennai.
Mm-hmm.
I am from ECD stream. I have two questions. One is the same question what you already answered. Where do we get the satellite images and data? Any trusted sites? I think you have given the answer, sir. Then one more question is, suggest any software for disaster prediction. And can we do the analysis using deep learning algorithm or artificial intelligence?
Yes. In fact, you can get the satellite data free of cost from various sites nowadays. So there is a US site which is called USGS. You have to type just USGS Landsat data. USGS Landsat image. So you will get the site where you can download the American satellite image. If you go to Bhuvan, 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 it is maintained by Department of Space, you can download. But recent data, if you want high resolution data, if you want, you have to procure from NRSC Hyderabad, which is National Remote Sensing Center Hyderabad. If you look at the site, there is a data center there. You contact the data center. There is a actually information given how to place the order, how to select the image, and if you ring data center, they would also help you if things are not clear. So you can, every satellite data has a cost associated. So you have to send the advance 100% amount to NRSC, which is a Government of India agency, sole agency. So you don't require any quotation also. Straight away, one can place the order. You give them 100% advance and then they will send you the satellite image. As far as the software part is concerned, nowadays also we have software which are open source software. So one can work on those software. Like there's a software called ILWIS, ILWIS. There's a software called QGIS. Okay, there's a software called GRASS, GRASS. So these are free download software. You can freely download them and work on them. But there are world-class software like the RDAS Imagine, ERDAS, RDAS Imagine software, or NV software, which you have to procure. They are module-based software, so you can procure basic module, you can procure the advanced module also. In the advanced module of, let us say, the ARC, RDAS, there's a provision to use artificial intelligence. There's a provision to use deep learning in ARC View Pro model, which is ARC View Pro, the latest version 9. There is a provision to use deep learning in that software also. But a lot of people are using freewares, means the software which are available free of cost on the internet, the data which is available free of cost, and then applying machine learning or the deep learning or the artificial intelligence technique to have better and better classification. Because all these techniques require a lot of ground information, lot of training data to the algorithm, and we can have from our reference data. It could be our maps, or it could be my field survey through GPS, or maybe UAV based map data collection which I am using. So I can give good input to these algorithms, and these algorithms are giving me better and better information extraction. So we are using all the three, artificial intelligence, deep learning, and machine learning technology in remote sensing also, because once you have a large data set, once you have a big data set, then very, very difficult actually to analyze it with the conventional mapping techniques. And if you want to automate the data processing and data analysis part, then certainly these new technologies are helping us a lot.
Thank you so much, sir. So it is very good information. Thank you so much.
Thank you. Any other question?
Anyone has any question, please come forward. I think, sir, there's no question, sir.
Okay, fine.
Okay, sir.
Thank you, everybody.
Thank you, sir. Thank you so much, sir, for your sharing your valuable time and knowledge. Thank you so much, sir. Could I close the session, sir?
Yeah. Yes. If there is no question, then I wish all the best to everyone.
Thank you, sir.
Thank you.
Thank you, sir.